When you think about the latest, like really massive artificial intelligence models, there is this expectation of near omniscience.
Oh, totally.
You imagine this digital superbrain that has, read the entire internet, can write code in a dozen languages, and can just instantly summarize a textbook. It feels like magic.
Right. It feels like we finally built a machine that just understands everything.
Yeah.
We naturally assume this kind of universal competence, right?
Yeah.
A system that can handle literally anything we throw at it.
Yeah, exactly. So I want you to imagine you're a high-stakes investor. You sit down at your desk in the morning, and your inbox is it's flooded.
Oh, I can only imagine.
Yeah, news reports, central bank updates, hundreds of dense corporate emails. And you think, well, great, I have this state-of-the-art frontier AI model. I'll just have it sort my morning inbox. You ask it to separate the critical signals from the absolute garbage, and it completely fails.
Just falls flat on its face.
It hands you a pile of irrelevant noise. And that jarring reality check is exactly what we are exploring today in our deep dive. We're looking at a truly fascinating new post from Thinking Machines Lab and Bridgewater AIA Labs.
It's such a great post.
It really is. The goal of this deep dive is to understand how we can teach AI taste and expert judgment, specifically in the high-stakes world of finance, and why custom-trained models are suddenly outsmarting the massive frontier AI giants.
Yeah, and it's a critical shift in how we approach machine intelligence because the general AI models that you might use every day, they're built to know a little bit about everything.
Right.
But what we are seeing in this research is that knowing a little bit about everything is completely useless when your job requires a very deep, very specific kind of intuition.
So the premise here is that these giant models are actually failing at something that seems pretty simple on the surface.
Oh.
But in the world of finance, outperforming the market requires alpha. Let's establish what that actually means in this context.
Sure. So alpha essentially refers to an investor's unique edge. It's the excess return you earn on an investment above the market average.
Okay.
But here's the structural problem. Every investor on Wall Street has access to the exact same public information. They all have the same Bloomberg terminals, the same SEC filings, the same global news feeds.
So they're all looking at the exact same screen.
Exactly. So alpha doesn't come from having more information. Alpha comes from having unique insight. It is built entirely on taste, experience, and judgment.
Because investors are just drowning in information, the source notes that reading isn't even the hard part of their job.
No, not at all.
The hardest part is triage. It's the small, repeated judgments, filtering, interpreting, segmenting the data to figure out where the useful signal is actually hiding.
Right, and they actually tested these state-of-the-art AI models on 6 specific tasks that are incredibly routine for an investment professional.
What kind of tasks?
Well, they looked at things like generic document relevancy, which is, given an investor's specific question, does this 60-page research document actually help answer it?
Got it.
Or email truncation, which is figuring out exactly where the meaningful content in an email ends and all the useless legal boilerplate begins. They also tested financial article relevancy.
And that article relevancy task is where the source provided an example that really illustrates the problem perfectly.
Oh, the headlines.
Yeah, they took 2 real headlines from the Financial Times. The first headline was, "Trump insists Greenland is his."
Right.
And the second headline was, "U.S. stocks close sharply lower after Trump threatens new China tariffs." To a seasoned investment professional, filtering these is instantaneous.
Yeah, it takes a human expert a fraction of a second.
Yeah.
I mean, they see the Greenland article and they instantly recognize it as irrelevant noise for a U.S. market investor. It's just political theater. But they see the China tariffs article and they know immediately that it is a critical signal that will fundamentally move markets.
But the AI just gets incredibly confused because structurally, both headlines involve the same political figure. They both touch on geopolitics, and they both technically relate to macroeconomics. Okay, let's unpack this with a quick analogy to make it a bit more relatable.
I love a good analogy.
It's like asking a total stranger to pick the next book for your close-knit book club.
Okay, yeah.
They might look at the rules and see the group likes historical fiction, but they don't know that Susan hates books about the 1920s, and Dave will only read books with a happy ending.
Right, right.
The stranger knows the genre, but they completely lack the contextual taste of the group.
And the AI operates just like that stranger. It understands the literal definitions of the words in the article. What it lacks is the localized, hard-won context that an investor has spent a decade building. A generalized model simply doesn't know what actually matters on a trading floor on a Tuesday morning.
Right. So naturally, I think the first assumption is that we just need to give the AI better instructions. Just tell the stranger what season and day like. We can just write a better prompt.
You think so?
But that leads us into a massive brick wall because prompt engineering completely failed in the scenario.
It really did. The data here gets very sobering for anyone relying on out-of-the-box AI to run complex workflows. The researchers took the absolute best frontier models available: Gemini 3.1 Pro, Claude Opus 4.6 and 4.8, GPT 5.2, 5.4, and 5.5.
The heavy hitters.
Exactly. They gave them a basic prompt describing the 6 financial triage tasks, and the average accuracy hovered right around 50%.
That is literally a coin flip.
Literally.
You might as well just guess if an email is important.
Yeah, so then they brought in the experts to write highly detailed instructions. They tried reframing the tasks entirely. They discovered, for instance, that if an article is about a small initial public offering, it is technically financially relevant, but a macroeconomic investor at Bridgewater just wouldn't care.
Right. Context is everything.
Exactly. So they instructed the AI to sort news into 3 highly specific buckets: relevant and interesting, relevant but uninteresting, and irrelevant.
Okay, so that structural change had to help somewhat, right?
It did. It moved the accuracy from a coin flip up to the mid-70s, but that was the ceiling. Even using automatic prompt optimization methods, the models hit a hard plateau. They could not break the 80% accuracy mark.
Which is a massive psychological and operational barrier in this industry. Investors demand an 80% accuracy threshold to actually trust a system in their daily workflow.
Right.
If an automated tool is wrong 1 out of every 4 times on a high-stakes trading floor, it is a liability. You just can't use it.
And throwing more money and compute power at the problem did not fix it. The researchers noted that GPT 5.4 costs 43% more than GPT 5.2.
Wow.
But the accuracy on these specific judgment tasks barely moved a fraction of a percent.
Wait, aren't these newer models like GPT 5.5 supposed to be vastly superior? They have trillions of parameters. If prompting is a dead end, how do you mathematically teach an AI intuition?
What's fascinating here is that we run into the philosophical limitation of language itself.
Okay, how so?
You cannot articulate taste in a static set of rules. Think about trying to explain to someone how to ride a bicycle by writing them a manual about physics and balance.
You'd fall over instantly.
Exactly. You can read the manual all day, but you will still fall over the first time you get on the bike. Taste is tacit knowledge. It is deeply ingrained pattern recognition built over years of seeing edge cases. An explicit prompt can only convey the intuition an expert is able to put into words, and the judgments that matter most are usually the hardest to articulate.
Wow, so you have to let the model experience those edge cases directly. It has to develop its own judgment natively.
Yes.
Which means abandoning the giant out-of-the-box models and fine-tuning a custom model yourself. But to train a custom model, you need training data. You need thousands of examples of perfectly sorted emails and articles.
And that requirement introduces a massive logistical nightmare. Because if you want an AI model to have Wall Street expert-level taste, you need Wall Street experts to label your training data.
And you cannot ask a top-tier Bridgewater analyst to spend 6 months clicking relevant or not relevant on 50,000 random emails.
No, absolutely not.
They are way too expensive, and frankly, their time is better spent actually analyzing the market. So the researchers initially tried the standard tech industry solution, which is using a data set from vendors who provide non-expert labeling. Basically, gig workers.
Yeah, and the models trained on that cheap data performed really poorly. The non-expert labelers didn't have the requisite taste either. When the researchers looked at the reasoning traces, they realized the human labels themselves were often just wrong or completely misunderstood the nuance of the market.
Which leads to the most clever workaround in the entire source document. They created this brilliant verification scheme to solve the data bottleneck.
Oh, it's so smart.
Since they couldn't afford to have experts label everything, they trained a cheap initial model on the flawed non-expert data. Then they had that newly trained model evaluate the exact same data it was just trained on.
Right, and if the model's answer matched the non-expert human labeler, the researchers assumed the label was probably correct, or at least straightforward enough to agree on. But the magic happened when the model disagreed with the original non-expert label.
Right. Only then did they escalate that specific contested example to the highly paid Wall Street experts to resolve.
It was an incredibly elegant synthesis of a human-in-the-loop system. Think about it. If the model can't even match an example from its own training set, then either the example is genuinely incredibly nuanced and difficult, or the original label was just flat out wrong.
Right.
This verification loop respects the expert's time by only feeding them the absolute hardest edge cases. It cleans the training set and creates a true gold standard data set without burning millions of dollars in expert hourly rates.
It's like having a junior assistant do the first pass on all the paperwork, and they only knock on the boss's door when they find a contradiction they just can't solve.
Exactly.
So we've solved the data problem. We have perfectly labeled edge cases. But feeding clean data into a model doesn't magically teach a judgment if the underlying math is wrong.
No, the training recipe has to be just right. They used a platform called Tinker from Thinking Machines Lab, which allowed them to iterate their training math rapidly without getting bogged down in hardware and GPU infrastructure headaches. And for their base model, they chose an open-weight model called Qwen 3235B.
Okay. And they started with a baseline training approach involving something called GRPO and importance sampling. Let's make sure we ground that for a second. GRPO stands for Group Relative Policy Optimization.
Right.
Basically, instead of just telling the AI this is the right answer, you let the AI generate a bunch of different answers, and it compares them against each other to figure out which one was best. And importance sampling just helps it focus on the most useful lessons.
Yeah, that's a great summary.
And that baseline alone got them a massive jump up to 73.4% accuracy, but they were still short of the 80% trust threshold.
So they needed to cross that line. And to do it, they made 3 major technical tweaks to how the model actually learns. The first was changing how they fed the data to the model, using a method called interleaved batching.
Interleaved batching.
Yeah. When you are training a model on multiple tasks like sorting emails and also judging central bank documents, you have to decide the curriculum order. Do you do all the emails first, then all the bank documents, or do you mix them all into one giant chaotic batch?
If I'm trying to learn finance, I would assume I should just focus purely on one specific task before moving to the next subject. Why would they mix the tasks?
Because if a model focuses entirely on one task for too long, it suffers from something called catastrophic forgetting.
Oh, wow.
Yeah, it learns the new task, but entirely forgets the nuances of the previous one.
Yeah.
But conversely, if you mix everything randomly, it can't find a pattern. They found that interleaving them, doing one batch of task A, then one batch of task B, in a round-robin order worked best. It improved accuracy by a massive 12.1% over fully mixing the tasks.
Here's where it gets really interesting. Think about how you used to study for finals in college.
Oh man, don't remind me.
Right. If you studied math for 5 hours straight, your brain would fry and you'd forget what you learned in the first hour. But if you took a practice test where question 1 was math, question 2 was history, and question 3 was biology, your brain wouldn't be able to get into a rhythm.
Exactly.
Interleaved batching is like studying 1 hour of math, then 1 hour of history, then 1 hour of biology, and repeating. It allows the model to learn the distinct boundaries of each task while keeping its overall understanding agile.
Yeah, it builds a much more robust neural pathway. Now, the second tweak was a mathematical change to how the model reacts when it makes a mistake. They used a specific loss function called CISPO loss with asymmetric clipping.
Okay, we need to translate that.
Fair enough.
Because a loss function is essentially the math equation that tells the AI how wrong its guess was so it can adjust its internal weights. But asymmetric clipping sounds like, I don't know, a haircut gone wrong. What is the actual mechanism there?
Imagine a teacher grading a complex essay. If a student makes a small formatting mistake, the teacher corrects it gently. If the student writes something completely unhinged and unrelated to the prompt, a standard AI loss function would drastically penalize the model, heavily rewiring its brain to avoid that mistake.
Makes sense.
But sometimes, overcorrecting for one bizarre outlier ruins the model's baseline competence. Asymmetric clipping acts as a cap on that penalty. The teacher says, "You got a 0 on this question, but I'm not going to subtract 50 points and ruin your entire semester grade."
Ah, so it prevents the AI from spiraling into the abyss from one single bad guess. It stops it from overreacting to extreme errors while it learns.
Exactly. That single mathematical boundary capping the penalty boosted the model's accuracy by another 10.1%. It created a much more stable learning environment.
Which brings us to the third tweak. On-policy distillation with strong teachers. I know distillation usually means taking a massive, highly capable model, the teacher, and having it train a smaller, faster model, the student. You want the small model to mimic the big one.
Right. But here, they used on-policy distillation. The reward function for the student model is penalized if its answers drift too far away from the teacher model's general distribution. It acts like an invisible leash.
Okay.
While the student model is experimenting and trying to learn the specific financial tasks, the leash keeps it from developing weird, off-the-wall behaviors.
But the truly inventive part of this is how they manage the teacher.
Yeah.
They don't just use a static big model. Every 20 steps of training, they would evaluate the student model's progress.
Yeah.
And if the student model hit a new high score in its validation accuracy, they would promote that newly smarter version of the student to become the new teacher for the next round.
Yeah. They ensured they were never distilling toward a stagnant model. The bar for success was constantly being raised by the model's own best performance. It was constantly chasing its own newly discovered potential, and that dynamic, self-improving process squeezed out a further 3.1% gain in accuracy.
So we have the perfect expert-verified data loop. We have Interleaved studying to prevent catastrophic forgetting. We have the asymmetric clipping to stop extreme overreactions. And we have the constantly evolving teacher. Does all of this actually yield a machine that possesses financial taste?
It worked phenomenally well. The final custom model achieved an 84.7% average accuracy across all the tasks.
Wow, it completely shattered the 80% trust threshold that the giant models couldn't even touch.
Yeah, and to put that in perspective, this custom model makes 29.8% fewer mistakes than the absolute best multi-billion parameter frontier model they tested.
Yeah.
It is objectively superior at this job than the giants of the AI world.
But it's not just about being smarter, is it? It's about efficiency.
Absolutely. Because this is a smaller, highly customized model, it achieved a 13.8 times reduction in inference cost per task compared to running those same queries through a frontier model.
A 13.8x cost reduction.
Yeah, it's massive.
Think about what this means for you listening right now. If you are running a project or a department or an entire business, you might not need to pay a massive premium to run all your daily operational data through a giant general AI that, knows how to write a sonnet in French, but can't accurately sort your industry-specific inbox.
Right.
The future isn't necessarily one omnipotent supermodel dominating every workflow. It's about building smaller, highly trained specialist models.
If we connect this to the bigger picture, the authors of the post call this differentiated intelligence. It is a paradigm shift in enterprise AI. Organizations will scale their capabilities not by buying a single giant brain, but by tuning specific models for specific organizational needs.
It makes total sense.
These specialized models will beat the frontier giants in both performance and cost every single time because they actually possess the contextual taste of the organization.
It is the ultimate hack for productivity. You aren't just automating a rote task. You are mathematically cloning the judgment of your very best people. We went from frontier models flipping a coin on basic triage to a brilliant data loop that respected human experts to a custom training recipe that actually replicated Wall Street intuition for pennies on the dollar.
It just proves that expert judgment is not magic. It is highly contextualized pattern recognition. And with the right data and the right mathematical boundaries, a machine can learn it.
So we have essentially cloned Wall Street intuition and built a machine that can flawlessly handle the daily noise. But, thinking about this practically, if the AI is doing all the grueling triage work flawlessly, what happens to the 22-year-old junior analyst sitting at the desk next to you?
Oh, that's a great question. It forces us to look at the life cycle of human capital. Traditionally, those junior analysts learn what makes good investment by doing this exact monotonous, grueling triage work.
Right, they put in the hours.
Yeah, they build their own taste by reading thousands of irrelevant Greenland articles until they intuitively recognize the subtle shift of a China tariff signal.
So if the AI skips the line straight to expert judgment and perfectly filters the inbox before the human ever sees it, what is the junior analyst actually doing? How does the next generation of humans ever develop that deep contextual taste for themselves if the machine is doing all the foundational learning for them? Are we, optimizing away the very process of becoming an expert?
It's a huge risk. We are solving the productivity bottleneck today, but we might be inadvertently severing the training pipeline for tomorrow's experts. It is a profound dilemma for any knowledge-based industry.
So next time you sit at your desk and look at that overflowing morning inbox, just remember your custom AI might finally be smart enough to sort it perfectly. But you have to wonder who is going to be qualified to sit at the desk next to you 10 years from now. Thanks for joining us on this deep dive. We'll catch you next time.